This video is going to go over what we did before I realized I was not recording and pressed record. So the first thing that happened was I talked about one of the homework problems. So there were a few homework problems from this homework set that were quote-unquote essays, and you had to write the proof for it. And I wanted to focus on number 25 because number 25 actually needed a piece of information that technically you could have filled out for yourself, you could have recreated, but technically it pulled on something from a previous exercise, an exercise that I actually had not assigned, and I didn't realize that this assignment had pulled from it. And essentially, the piece of information that you needed to use was the fact that we have this kind of equivalence between P and P or P. So we have the one direction of we can always add on an or Q, but if you add on the same thing itself, then you can go both directions. So there was this piece that you didn't actually have, and again, you could have actually gone through the process used to prove this in the other exercise, but it's much easier if you just know that you can use this, and that was my fault for not realizing that this number 25 pulled on that. So I also went through the entire number 25 to also try to kind of illustrate how proofs work and how proofs are kind of used, because it's not always that you know exactly what to fill out right away. Sometimes you have to do a lot of work off to the side. So for number 25, what you're given is you're given P or Q or P or R. And so this part is given. And then what you want is you want to come out to, not R implies P or Q. So you somehow want to get from the given to the end. Now with this one specifically, you might not know how to start from what's given. So sometimes when you're not entirely sure where to start from what's given, why don't we take a look at what we want? So we want not R implies P or Q. Okay, I'm sorry for the bit of a jump here, but I wanted to pull up our rules and kind of bring them over here because that's going to make talking about this a lot easier. So I've rewritten what I want over here. Now let me try to actually work backwards from what I want. So this is what I want, and now I'm going to come over to my rules, and I'm going to look and try to see some rules that would kind of help me achieve this. Well, I know that I'm going to have to somehow get an implication. I don't have an implication to start with. So one rule that I'm definitely most likely going to want to use is the implication rule, which is this second rule under the equivalences. So I know that if I want not R implies P or Q, that must have come from not R, because it's not whatever was the first thing in the implication, or P or Q. So I know that I can use the implication rule to get from one of these to the other. Well, that's helpful because that now has a string of ors in it, and what I'm given is a string of ors. Also, I want to note that this is easily derived from double negation. So now I've noticed that I can easily derive this not R, and essentially, so if I use double negation on what I have here, so I use the double negation, I could change that to R or P or Q. Well, that's starting to get me somewhere, because now I realize that what I have can hopefully end up looking like that. The thing that I don't have is I have two P's to start with, and I only have one P in the thing I'm saying that I'm going to need to want. But since we're allowed to use this piece here, if I can get those two P's together, then I'm able to condense them into one P. Now the other thing we want to notice is that with the given statement, it's a string of ors. So since it's a string of ors, we can essentially arrange this into any format we want. It would take a lot of different steps of the commutative rule and the associative rule, which are the 1, 2, 3, third, fourth, and fifth rules on our table here. But we could get there. We could essentially use those rules multiple times to rearrange this into any format we want. So that seems like the best course of action. So let's start and try to do that. So let's go ahead and start trying to write our proof, because it looks like if we can get here, then we're good to go. And we should be able to get there by rearranging what we have. Using this new piece of information we have, we should get to what we want. So first thing we're going to want to do is, this is of course just given. So we want to start rearranging this. So there's a couple different ways you can do this. But especially how WebAssign was going to do it is they're going to start with the associative property, which is essentially going to change, they start with the commutative property first. And they reorder this first term to be Q or P instead of P or Q. So they use the commutative property on number 1. And then they use the associative property. So the associative property is essentially how we're going to move the parentheses. So we're going to end up with Q or P or R. And this is the associative property on 2. Once we're there, we can use the associative property again inside. So we're going to use the associative property on this piece here, getting us Q or P or R. So that's the associative property on 3. And now I can use this new bit of information that, again, I didn't realize you were going to have to use, but we can use now, to change this P or P into just one occurrence of P. Now, in WebAssign, this is referred to exercise 20, and that was done on number 4. And now we're so close to getting what we need to be able to run up to this implication. We just need to rearrange things a little bit more. So the first thing we're going to do, again, there's multiple ways you can do this, but we're going to use the associative property. So there's different ways. You could use commutative first and then associative, or, there's a couple different ways that you could go about doing the same thing. It just might take slightly more steps. So we use the associative property and then the commutative property. And now we're essentially here, and we can now essentially run back up through these steps that we figured out, kind of working backwards, to be able to get to the implication that we finally wanted. So the first thing we did was we worked out this double negation. So we're going to use double negation on that R piece. So we're going to have not R, or Q or P. And in fact, sorry, I think we needed one more commutative step first. We need to make sure to make these right. So that needed to be the commutative property first. And now we can use, sorry about that, double negation, not R, or P or Q. So double negation on 8. And then from that double negation step, that's where we use that implication rule to get to the implication. So this last step of this proof would be not R implies P or Q, and that's from implication on 9. So that's how number 25 in the homework was going to work. And yes, you would have had to write all of this out. I did also note that WebAssign does seem to kind of accept anything when it comes to these essay questions. So also, if you kind of just want to say, well, I understand it, I'm just going to type in the last line. That's perfectly fine. So the last thing we did before the recording started in is we started going through the end of 1.2 notes, and we did this example right here. So this example should look somewhat familiar because we did one of those very large truth tables for this as well. So here we have, if Andy is hungry, which we're calling P, and the refrigerator is empty, which we're calling Q, then Andy is mad. That's going to be a true statement. We're also given that Andy is not mad, so not R, and the refrigerator is empty, so Q. So those are essentially going to be the things we're given. P and Q implies R, not R and Q. And we want to show that Andy is not hungry, so we want to prove not P. So we're going to go ahead and try to do that. So the first thing we're going to do is write down our givens. So we're given not R, we're given Q, and we're given P and Q implies R. So those are all givens. Now pulling up our rules on the side again, let's kind of work backwards. So we want not P. So let's go ahead and look through our rules and look for something that might give us not P. Well, one thing that looks really potentially helpful is this rule here, which is going to be modus tollens. So this modus tollens is telling us that if we have not Q and P implies Q, that we can get not P. But notice we can also make that whatever letter we want. So we can change this to R and R. Well, we have not R, and we have an implication that goes to R. Now, it's not the right implication, but if we can somehow change that implication into just P implies R, we'd be good to go. Well, let's look at our rules and see if anything can help. Well, we have this one rule down here that says if we have P and Q, we can just change it into P, which is exactly what we need. So if we go back to our proof and we use that rule there, which is called simplification, we can change line 3, so using simplification, on line 3, we can turn that into P implies R, which is exactly what we need for modus tollens. So then our last step is just modus tollens on 4 and 1 to get us not P. And now we have the thing that we wanted. So essentially, with these proofs, sometimes it's easier, and definitely, again, proofs don't always lay themselves out. You kind of have to come off to the side, do a bunch of scratch work, potentially work backwards, potentially work forwards. And sometimes you have to do a little bit of both and then try to meet in the middle here. So here what we did was we put down all of our givens, and then we went over and we said, okay, well, this is what I want, and we looked for any potential rules that would help us get that. We found modus tollens, but then we needed to try to take the things we were given and turn them into the things we needed to use modus tollens. So then we went back and looked at the givens, looked at our rules, said, are there any of these rules that can change what we're given into what we need? And if you recognize that the simplification rule can change the P and Q into just P, giving us the setup we need for modus tollens, then you know you've now met yourself in the middle. You know how to change the givens into what you need to finish the proof. So proofs do take a lot of time. They just take a lot of practice to master. I know that's an unfortunate way to put it. It's unfortunately just kind of how it goes. So I will be putting up some extra practice for proofs on Blackboard. Also know that in terms of quizzes and exams, it will be more like the WebAssign homework where you just had to fill in the reasons and the steps. So essentially these statements here will be already laid out for you, and you just have to fill out kind of what rule was used. Okay, so this is about where we ended before I realized I wasn't recording. So the rest of these lecture notes will be in the usual recording.